just got a few photos to show you. We'll just look at a couple of basin types now that we've done all of the calculations for calculating our lime soda ash additions. So we've talked about paddle wheel flocculators. We can use these for flocculation. And you can see this is an open tank, and these, it's hard to see, but in here are the paddle wheel flocculators. And then you see the sedimentation basins. We also often use an upflow clarifier. If we were visiting the East Lansing plant, as we normally would do that, we would actually see these in operation. And this is a rapid mix, flocculation, and sedimentation basin all in one unit. So we have a rapid mix here. We're adding the influent, we're adding the chemicals. You can see your chemical feed here, your influent feed here. We then have a flocculation basin on this inverted cone on the inside. So this is typically a turbine type system. The water flows down through this flocculation basin and then up through the sedimentation basin. It forms what we refer to as a sludge blanket. You can actually, when you look at this, you can actually see the layer of sludge. The water flows up through here. It flows typically out over a weir and then into a channel and onto the next treatment process, which in most cases would be a filtration system. So in East Lansing, what they do is they use upflow clarifiers as the primary stage one, and then they actually have ferric chloride to remove some turbidity because they have sludge coming in from their sludge drying pond, or sorry, water coming in from their sludge drying ponds. So they use ferric chloride, and then they have a second sedimentation system. So that's a conventional sedimentation basin, and then the water flows into filtration. Giving you some design criteria for conventional basins. These are typical. This is for softening. I'm not going to spend a lot of time on this. And then I've given you design criteria for upflow clarifiers.
The line softening process helps us remove calcium and magnesium that makes the water hard. The city has multiple wells that they pump up to the water treatment plant, and from there it enters aeration. Water cascades over metal, and this is where the actual softening of the process happens. And
how did I skip that one?
Over metal statues, basically.
What I want to stop and show you here is in many cases, the CO2 levels are quite high. And as you saw that we add a significant amount of lime to neutralize the CO2, but we get no hardness removal. So essentially that's costing us money in terms of chemical addition and sludge production. Also in many cases, for instance, the East Lansing system, the MSU system, iron and manganese levels in the groundwater are quite high. And often we want to remove the iron and manganese levels in order to produce higher quality water. Now we can use an approach like MSU is using with an ion exchange system. But the system that they've chosen at MSU doesn't remove hardness. It removes iron and manganese, but it's not going to remove hardness. What this system is doing is it's aerating the water. So by aerating the water, that purges off some of that CO2. It also converts the iron 2+ to iron 3, so from ferrous to ferric, and it converts manganese 2 to manganese 4, and both Fe3 plus and manganese 4 plus are less soluble than their reduced species. So by doing that, they can precipitate out the iron and manganese. At the same time, they can strip some of that CO2, reducing the amount of lime that they need for reaction 1. So that's what they're doing in this part of the process.
And combines with oxygen to help iron precipitate out, and it also releases hydrogen sulfide and carbon dioxide gas. The water then proceeds on to the solid contact unit, and this is where the actual softening of the process happens. And the lime is the chemical that actually helps remove calcium and magnesium as it's stirred together with the water. The water then moves on to
This is an upflow clarifier. So you can see the mixing occurring in the middle. You don't see the flocculation because it's in that inverted cone under the sedimentation basin.
carbonation. As part of the solid contact process,
This is a weir. So you can see, drew the arrows that the water flows up. It flows up through the sedimentation basin, through that sludge blanket, and then out over a weir into a channel, and then it would move into a larger channel onto the next unit. So notice in this system, the engineer mentioned that they use recarbonation. Okay, so after softening, they're recarbonating, they're adding more CO2 in order to reduce the pH.
filtration is done with 2 types of media. It's anthracite coal and sand. And the purpose of the filters is to remove particulates from the water before it's sent out to the distribution system. From there,
So we haven't talked about filtration yet, but you can see these are the filter beds here. The sedimentation doesn't remove sufficient amount of turbidity in order to distribute that water. So then the water has to then flow through a filtration basin. You can see the empty one next to it. And basically what it's doing is it's flowing through sand, and we remove that additional turbidity in the sand filter.
the water, once it's filtered, heads on to the clear well. It's fed with some chlorine to help disinfect it before it leaves the plant so that the water is safe to drink in the distribution.
So any questions about this? It's just a short, I'm just going to play this short portion of the video. You can watch the rest of it later so that you get a better sense, you can look at the whole system, but I wanted you to get a better sense of the system. I've got one other tour we can quick do, and this is Plainfield Township, Plainfield Township's treatment plant.
This is water from 11 wells located in 2 separate well fields around the area. These wells have the capacity to pump more than 19 million gallons of water per day into our treatment plant, where the water is then treated to meet or exceed federal and state requirements for safe, clean drinking water for more than 40,000 residents and neighbors. When the water first enters the plant, chemicals that help keep our bodies safe are carefully measured and added. Aluminum sulfate helps to remove particles, while fluoride prevents cavities, and chlorine guards against bacteria. The water is then softened. Using lime from the UP, the water heats by chemical reaction and creates a milky-looking slurry that
So I mentioned that they add lime. It's same thing in this system here. They're adding calcium oxide. What they need to do is they mix that with water. It actually creates a significant amount of heat in that reaction. It's an exothermic reaction. And then that slurry is then what's pumped into the reactor. So that's what was pumped into your rapid mix basin, either in an upflow clarifier or in a conventional rapid mix basin. So you take calcium oxide, react it with water to produce calcium hydroxide.
saturates the water. The mixture causes heavy particles like calcium and magnesium to sink to the bottom, while the softened water goes to the filters. The filters consist of bell-shaped tubes that contain layers of a semi-permeable substance, including gravel, fine sand from Iowa, and anthracite coal. After the water is run through the filtration system, the water is...
So notice that filter, they give you a cross-section, so you have a sense of the gravel at the bottom, that's basically your support, and then you have sand. They actually, in this system, have anthracite coal. We'll talk about that much later in the semester, but basically what they're doing is they're using the anthracite coal to sorb or attach to soluble organic material. So the anthracite coal is really not a filtration process. It's a sorption process or an adsorption process where the organic chemicals are attaching onto the surfaces of the anthracite coal and they're removed that way versus a physical separation in a filter.
Pumped into one of our on-site storage reservoirs, where it stays until being repumped to one of our 14 storage tanks, and then on to customers. We typically keep an average of 14 million gallons in storage before it is shipped through more than 300 miles of pipes that distribute water to homes in Plainfield.
So notice here, they talk about 300 miles of pipe. That's not unusual. This is for a township. City of Flint, for instance, had over 700 miles of pipe. We need to make sure that the water that we distribute, not only it meets all the regulations at the plant tap, but we need to make sure that it meets all of the regulations at each one of these homes that you see in the photo. So what we need to do is we need to make sure that the water is what we call stabilized. That means that what we don't want is we don't want the water itself to be dissolving the pipe. We don't want lead leaching out of plumbing fixtures, service line materials. We don't want iron leaching from dissolving from the pipes. So the last thing we'll look at with lime soda ash softening, we'll do this on Wednesday, is how do we ensure that we have what we call a stable water so that we're not dissolving, releasing metals from the piping network.